Okay, so today we're going to complete a question on developing an oblique truncated cone. So first of all, you should have all seen the AR model. So I'm just firstly just going to show you what that would have looked like. So here we have the model that we're going to start off with. So the teacher would have handed around a 3D printed model of this as well. So you all should have a look at this to start off with. So it's basically a truncated cone with an oblique cut. So let's go back here now. So this is what we're given to start off with. This is the question. So the question reads, develop the given oblique truncated cone from the given plan and elevation. So as you can see, we're given the elevation on top and the plan below. So we're going to start off by drawing these. So these are the dimensions that we're going to use. So we can see the base of the cone in plan is 60 mil diameter. And for to find the apex of the cone, we're going to come out from the center, out 43, and then we're going to bring this straight up. So when we continue these lines on, we're going to find our apex up here. So another way that we're going to use this point down here again. So I want you all just to mark this point down here. So to find the cut in the elevation then, it's simple enough. We're going to draw a line, a light line across 15 mil and a light line across 40 mil up from our base. So that's going to give us the low point of the cut and the high point of the cut up here. So moving on from that then, we're going to move on to the next step is dividing the circle. So as you can see, we're going to divide the circle up into 12 equal parts. So we should all know how to do that, and if you don't, there's a little hint up here as well. So we're going to use a 60, 30 degree set square. So we're getting our 12 equal sections, and we're going to bring all of these up to our elevation. Once we have this done, we're going to join all these points back up to the apex of the original cone. So after this then, we're going to move on to finding the radians and finding the true length of the radians. So we should already have all of the elevation and plan completed. So what we're going to do is we're going to use the point again. So the red arrow is showing us. So we're going to use that point as our center of rotation. So we're going to bring each point around, and we're going to bring it around to this line here. So this horizontal line, we're going to rotate all these points around. When they meet the horizontal line, we're going to bring them vertically up. So we're going to label all our points as well. So we're going to bring point 2, for example, around, up, and we're going to get it up here. Once we have that done for all 6 points, we're going to join them back up to the original apex up on the top. So I want you all to think now, why do we not bring point 1 and point 7 up? Why don't we have to bring that around? Why don't we have to try find the true length of them lines? So we should have all figured out now that the two lines, so the lines that go with point 1 and 7, they are already true lengths. So we don't need to find these lines. We don't need to find the true lengths of these. We already have them. So we're only going to use points 2, 3, 4, 5, and 6. So they're the only ones we need to use. So moving on from this then, we're going to take the points where the oblique cut meets these lines. So where these lines meet the oblique cut, we're going to take that point, we're going to bring it horizontal across until it hits the corresponding line. So for example, line 2 here, so we have point 2 here, bring it up. So this is line 2, going to bring it across, and it meets our line 2 in orange as well. So once we have this done for all 6 of the points, we're going to just heavy in the lines from where we found back down to the base. So we should heavy in all of these lines. So we'll have the 6 lines drawn in heavy then. And we're ready to move on to the next step.
Okay, so step 6 now. So we'll draw in the cone like it's not cut in the plan. So to do that, we're going to drop down the apex from the elevation. So we'll get this point and drop it vertically down to find this. Or alternatively, you could measure from the edge of the circle on the plan across 13, which you'll find the apex also. And if you look at the hint there, it's the same point as the center of the rotation to find your radians up here. Okay, so step 7, we're going to drop down the lines from the cut plane to the purple lines in the plan. So it's going to be along this animation line. We're going to drop them down to the plan. So the students can draw in the circles now, but or the circle on the plan, but we're going to leave it out to the next step to avoid confusion. So step 8, draw the auxiliary view by drawing lines perpendicular to the cut surface. So the hint there says 90 degrees, so you should all know that perpendicular means 90 degrees. Next, we're going to project the lines. All the lines are going to go parallel to them two red lines where the animation arrows have gone. So it's all them green lines. Now take the width from that circle in the plan, indicated by that 15.37 mil, and we're going to measure it out on the auxiliary view, indicated by this red arrow.
Okay, so now we're going to start the actual development of our truncated cone. So first we're going to draw our circle of 60 millimeters, and we're going to extend a line vertically the same distance as 0.7 all the way up to our original apex. So now, using our true lengths from our radians that we got earlier, we're going to start making arcs along this vertical line here, and we're going to label them from 1 to 6, since we already have 7 on the circle here. So what you're going to do is you're going to need your compass and mark from the top of this apex here and down to number 6, and then just going to mark off the arc here. So our next step now is to create our division of our developments to help us implement our sections for later on. So for example, using your compass, take the distance from 0.7 in plan to a point to 0.6. Using this as a radius, make a point on the corresponding arc from the previous step. Once that is completed, all we need to do now is join each of our intersecting points along each of the arcs back to our vertex here from earlier. And what we're going to do then is just join all our intersections together, and we'll get this curve here, which is going to be the base of our development. Okay, so our next step then is to transfer the true lengths from our radians to the corresponding newly drawn lines in our development. So what we're going to do is we're going to take, for example, here line 1, we're going to take its true length and carry it over and mark it off here. And we'll repeat that for the other remaining radians here as well. So for example, we're carrying over radian 1 and mark it off here where it corresponds with its intersection on the arcs. So then you can see here we've continued on that, and we've drawn in the remaining radians as well. So all that's left to do now is to basically just make our line across each of the points here that we just drew in with our lines. And this will give us the kind of final complete development of our cone being flattened out. And then our final step then is all we have to do is transfer our true shape here we got earlier and bring it over to our development now. And this basically results in our complete development. And then let's say for afterwards, should you want to heavy in certain points, we'd advise heavy in our original elevation, original plan, and make sure to add this hidden detail here, also add in the truncated truncated surface, and also then heavy in our development as well. And that is the question completed.